Okay, everybody, welcome back. This is Simplifying Radicals lesson part 2. Good news, Elliot has gotten himself some water, and he can now drink his water. So this is the Simplifying Radicals part 2. We simplified the square root of 864 to be 12 root 6. We simplified the cube root of 1600 to be 4 times the cube root of 25. And if those examples look weird to you, you should go back and watch part 1. If you're okay with part 1, let's talk part 2 now. Part 2 is going to involve numbers and variables. And if you can do these 3 examples, I'm going to be honest with you, you're going to be able to pull off any problem that we do on a quiz or a test, because I put everything in these examples, everything that you could possibly encounter. And I'm going to do 3 and 4 as a teacher, and I'm going to do example 5 as I would do it if I was just doing these problems on my own without talking to students. Okay, so we're doing the square root, there's like a little imaginary 2 there, of 125x, m to the 4, w to the 8, and n to the 7. Now, I recommend treating this like 2 separate problems. Simplify your square root 25 how you normally would, what your favorite way to simplify these are. Simplify these ones differently. So anyway, the square root 125, I can divide a 25 out of 125, so this becomes square root of 25 times square root of 5. Square root of 25 is 5, so the number portion becomes a 5 root 5. The number portion, as I mentioned before, in a square root problem, they can these numbers can escape, or these variables can escape, but they can only escape 2 at a time. So there's only one x there, so that x is going to have to stay in prison. This m to the 4, well, all 4 of them are going to be able to get out because it's an even number of 4s, or m's. There's an even number of w's, so they're all going to be able to escape. But then of the n's, 6 of them are going to be able to escape, so n to the 6, and 1's going to be left behind. Poor one that's left behind. Anyway, the m escapes, and they both, so that when they escape, you got to think, so it's m to the 4th, but it's square root of that, so it's to the 1/2, and 4 times 1/2 is 2, or 4 divided by 2 is 2, so it's going to become an m squared. The w to the 8, same thing, 8 times 1/2 is 4, or square root, so 8 divided by 2 is 4, so w to the 4. N to the 3, 6 divided by 2 is 3, and then left on the inside is the lone x and the lone n. So at that point, kind of combine these 2 problems, and you end up with 5, the m squared, the w to the 4, the n to the 3, and then left on the inside is the 5, the x, and the n. This is how I normally go about solving them, just on in my own work. I'm not sure this is the easiest way to understand it, though. Maybe a good thing to do is to break it into the ones that are going to escape and the ones that are going to be left behind. Now, in the 125, the 25 is going to escape, but the 5 is going to be left behind. The x is going to be left behind. The m's, they're all escaping. The w's, they're all escaping. The n's, 6 of them are escaping, 1 of them is being left behind. And now the square root of 25 is 5. 4 divided by 2 is 2. 8 divided by 2 is 4. 6 divided by 2 is 3. And then left behind is a 5, the x, and the n. Yeah, Elliot likes that technique. I'm going to show this technique for the next 2 examples. That seems pretty clean. All right, example 4. Example 4 is a cube root. And this is the first, like, examples 1, 2, and 3. Those are honestly a little too I don't want to say simple, but they're just not complicated enough to be on a quiz or a test. So you will not see a square root on these, but you could see a cube root or a fourth root, or a fifth, I suppose. So let's go cube root 648, x to the 9, m to the 2, w to the 19, c to the 3. All right, so cube root. As far as the 648 is concerned, I need to think of what divides out of 648 that I know the cube root of. So let's see, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5, 125, 6, 2, 16. Ooh, it looks, I bet 216 divides out. 216 times 3 is 648. So I bet I'm gonna use that 216. So the 216 is what's going to escape, and 216 times 3 is 648, so that means that a single 3 would be left behind. Now, it's a cube root prison, so that means that they can only escape in groups of 3. So of the 9, 9 is divisible by 3, so all 9 x's are going to be able to escape. Oh, sorry, M's. There's only 2 of you. You're stuck behind. W. OWs. A lot of you. But you can break out in groups of 3. And 3 times 6 is 18. So I know that 18 of them are going to escape, but then left behind is going to be 1 of them. Now, there's 3 C's, so they'll just be able to hold hands, and all of them will be able to get out. Now, cube root of 216 is 6. So we have cube root of x to the 9. That's the same thing as x to the 9 all to the 1/3 power. So it's 9 times 1/3, or just 9 divided by 3. 9 divided by 3 is 3, so you get x to the 3. 18 divided by 3 is 6, so w to the 6. 3 divided by 3 is 1, so c to the 1. And then what's left behind, there's that single 3, the pair of m's, and the w. They were left behind in their prison. Poor them. Okay, last example for you. Example 5. This is another test-worthy problem. Let's say we had the 4th root of 243, x to the 3, m to the 8, w to the 10, c to the 4. Alright, 4th root. So we need to think what to the 4th power. 2 to the 4 is 16. 16's even, 243 is odd, it's not dividing out. 3 to the 4, that's 81. 81 times 3 is 243. Oh, that's right. 243 is the same thing as 3 to the 5th power. That's one of the memorized ones. So I'm going to use the 81. So the 4th root of 81 is going to escape, and then who's not going to escape is going to be a 3. Because 81 times 3 is 243, and I know that the 4th root of 81 is 3. Okay, now they can only now we're getting some high security, so they can only escape 4 at a time. That means the x cubed, they're stuck behind. The m to the 8, well, if they can go in groups of 4, all of the m's are going to be able to get out, so it's going to be m to the 8. Of the w's, well, 8 of them will be able to escape, but 2 of them will be left behind, and then all 4 of the c's will escape, so c to the 4th. 4th root of 81 is 3, and like I've shown in other examples, if I'm doing the 4th root of m to the 8, that is the same thing as m to the 8 raised to the 1/4, so I get m squared. Basically 8 divided by 4. So m squared. 8 divided by 4 is 2, so w squared. 4 divided by 4 is 1, c to the 1. And all these poor suckers, they're stuck inside, at least until the prison fills up some more so that they can have some friends that they can escape with in groups of 4. Okay, shortcut. I don't like this shortcut. And if you're still paying attention, maybe you'd be interested in the shortcut. Shortcut. For that I use mixed numbers, and I don't like this shortcut because of the mixed numbers. Now the 4th root of 243, you're just going to want to work that out on the side. So you've got 4th root 81 times 4th root of 3, which becomes 3 4th root of 3. Then all of this stuff. Think of it as being x to the 3rd, m to the 8, w to the 10, c to the 4, all raised to the 1/4 power. And if you distribute, you get x to the 3/4, m to the 2, w to the 10/4, which simplified. We want to keep that 4th exponent, or the 4 there. We don't want to reduce it, and not using this trick. So 10/4. That's big 10/4, and 4/4. C to 4 divided by 4 is 1. Okay. Next, keep the 3/4, keep the squared. Now think of this instead of a improper fraction. Let's think of it as a mixed number. 10/4 is the same thing as 2 and 2/4, which is the same thing as 2 plus 2/4. So this could be viewed as w squared and w to the 2/4. So basically I broke up this improper fraction into a mixed number, and then the c to the 1 stays c to the 1. Okay, so this x to the 3/4, because this is less than 1, this stays on the inside. So this becomes x cubed. Hey, you guys, I need you to be quiet for a couple minutes. Thank you. This is less than 1, so it becomes 4th root of x to the 3rd. This is greater than 1. It's an m squared, so that escaped along with this 3. Ugh, and this 3 was stuck on the inside too. Elliot's going to start over his answer. He's gotten sloppy. Outside of the root are all of these numbers that are not fractions. So I have this 3, I have this m squared, I have this w squared, and I have this c to the 1. Those are all whole number exponents, so they are on the outside. Now stuck on the inside was this 3, this x to the 3/4, which would be an x to the 3rd 3/4, and the w to the 2/4 would be a w squared. I don't like this shortcut, but it is a shortcut, and people that like running through these quickly, that technique tends to work. Anyway, that's simplifying radicals, and I really hope you watch this lesson so that you aren't completely lost on Thursday. Have a great night, everybody. I'll see you tomorrow. Bye-bye.